Hi, my name is Emiliano Ceron, and I'm going to present my research project, which is about interstellar travel. Well, let's start with the hypothesis and my research question. And the research question was, will humans will become an interstellar race in the next 200 years? And my hypothesis was that I think that humans could become an interstellar civilization in even less than 200 years. And it is because that history has shown us that our technology advances at an exponential growth. And if we keep looking for a way to travel through space without any complications of time, food, fuel, we could become an interstellar civilization even faster than we think. And for this research project, I made a, a Google poll to know what people think about this this topic. Well, the first question was, do you think the space revolution is important for the human race? And well, 95% of the people answered yes, and I think only 1% of the 20 answered no. So I think, yeah, that a lot of people are interested in this topic, but and they think it could be the solution for our future crisis. So yeah, the next question was about, do you know how many years it would cost humankind to reach the nearest star with our actual technology? And there were three answers: 100 years, 2 years, or 6,300 years. And just a half of the people answered correctly. The 6,300 years, and 30%, 35% of the people answered that we could arrive there in 100 years, and 15% answered 2 years. And well, the next question was, in how many years from now do you think humankind will have the technology to reach another solar system? And the answers for this question were very varied. And 25% answered less than 200 years. The other 25% answered more than 200 years. 35% are answered 100 years, which they they share the same opinion as I do. And 15% answered in 50 years. It could be possible, but in the next diapositives, I'm going to show you why I think it couldn't be possible in the next 50 years, but it could be done in less than 200 years. And the next question was, do you know what is the maximum speed that an object can reach? And only the half of the people answered correctly, that the nearly three 300,000 kilometers per second. And yeah, that was the correct answer. And the other half answered between infinite or 1 million kilometers per hour. And the final question was about a rapid drive engine, if you know what that is. And this it was surprising to me, because I'm going to show you why this was surprising. But only 95 only one person answered correctly, or answered that he knows about this engine, and the rest of people doesn't even know what that is. So I'm going to show you my literature review. And the first I looked for was the speed that any object can travel. And yeah, indeed, I confirmed that nothing can travel faster than 300,000 kilometers per second, which is the speed of light. And this is because whenever you travel, when you travel faster, you require more energy to travel faster, and your mass increases when you travel fast. So if you travel as fast as the speed of light, you will require nearly infinite energy to achieve that speed. And that's why only massless particles can travel at that speed, like the photons or other subatomic particles. And the next thing I looked for was the fastest human-made object, which it has a speed of three 330,000 miles per hour, which it was the Solar Probe Parker, which was launched in 2018. And if that speed sounds crazy here on Earth, it is only equal to 0.05% of the speed of light, not even 1% of the speed of light. And yeah, it is very, very, very hard to achieve even 1% of the speed of light because of the fuel, of the propulsion system, the mass of the spaceship or this of the probe. And the closest star to our solar system is Proxima Centauri, which is 4.2 light years away. And yeah, that is our closest and our closest star. And the other stars are far, far, far away. And even it is the closest, it is far beyond our human limits. So I searched and I looked for the time we 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 would spend traveling with our actual technology, and we will last 6,300 years to get to Proxima Centauri if we use the solar probe Parker to reach this solar system. And another problem, which is not the speed we have, is the the time problem. And yeah, as Einstein stated, with the relativity, um, the time is relative, so it is not an universal clock. Each body or yeah, each body has its own clock. So when you travel at great speeds, your clock, your own clock slows down, and for you it could only, let's take for example, if you travel at 99% of the speed of light, uh, for you it would take 2 years to reach Proxima Centauri, but for the people which are observing you from the Earth, it would take more than 4.2 years. So yeah, the time is relative, and that is a problem because if you travel at a great speed to another solar system and then you come back to Earth, for you it might be only 8 years or 6 years, 4 years, but for the people on Earth it would have been like a decade or 2 decades. So yeah, it is a big problem. And another thing I look for is that the universe is expanding at a constant rate. And this is a problem because not in small scales like our own galaxy, but if we in the future want to reach another galaxy, well, it is expanding 4 kilometers each second and per megaparsec. This means that every 3.3 million light years farther away than from our galaxy, it appears that 74 kilometers per second are faster. It's like the more space between the galaxies or the objects, the more space increases. For example, if we are 1 block away from a star, it will increase to 2 blocks and then to 4 blocks and then to eight blocks. But if you are far, far, far away for, let's say, for example, 10 blocks, it will be 20, then 40, and so on. So each time the universe expands even faster and even reaching the speed of light, but it isn't an actual speed, but an expansion rate. And the last thing I looked for was the fabric of space-time. And as Einstein stated, This can be manipulated, folded, expanded, or shrunk. So with all this in mind, I'm going to go to the next thing, which I think is a solution for all these problems, and maybe our key ticket to another solar system or even galaxy, or who knows, even another universe, or the key for the non-observable universe. And it is the warp drive engine, which I mentioned in the past minutes. So what is a warp drive engine? And thanks to Einstein's special relativity, the a Mexican young named Miguel Alcubierre, he managed to create an equation to travel way faster than the speed of light without breaking any physics, any law of the physics. And this method consists on stretching the fabric of space-time outside the bubble that surrounds a spaceship. And this bubble is like some kind of bubble that deforms the space-time. So in front of the bubble, the space becomes shorter, and in the back of the bubble, the space becomes larger. And actually, this is not a moving method, because the space between the spaceship between the in the bubble doesn't move at all, but the space that surrounds that bubble moves. So that's why we can achieve these incredible speeds, and we can travel even way faster than the speed of light, because you are not moving. So you can travel, you move the space around you, so you get to another point. But the only problem in this travel method is that it requires negative energy, and that is something that we don't know where to find, and we aren't even sure if that exists. But I think in the future it could be solved, because there has been an an experiment by NASA that showed that in very, very, very small scales, in quantum scales, there is energy coming from nowhere between two plates. So if we search more from that experiment, we could find that that negative energy that we are looking for this for this project. And well, in my conclusion, I conclude that with traditional space traveling methods, it is impossible to reach another star, solar system, or galaxy. But if we use the warp drive engine, if we find a way to harvest this negative energy and use it in the spaceship, we could use it as the best viable way to travel through space. And I put this graph right here because it shows how the technology has grown exponentially in the past 8,000 years. So yeah, nearly in the 2000s, the technology started growing at a very, 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 very fast rate. And we are now reaching a point where the technology that we have discovered is helping us to discover new technologies and new traveling methods, new energy, and we are looking for more things about quantum mechanics. So yeah, these things could get us to the negative energy, and in the future to traveling through space or to other solar system, galaxies, or stars, and who knows what we will find out there. Thank you.